This video we're going to look at variable acceleration. Last year in AS we had seen constant acceleration. We've some formulas here for constant acceleration. So this is where the acceleration stayed the same the whole time. So you have v is equal to u plus at, v squared is equal to u squared plus 2as, s is equal to ut plus a half at squared, and s is equal to a half u plus v upon t. There was an extra one we had as well, which would be worth adding into your notes. This extra one is s is equal to vt minus a half at squared. So it's very similar to this one, but instead of u, it's v, and then the plus becomes a minus. So it's very easy to remember. Okay, this year what we're going to look at, however, is variable acceleration. So this is where the acceleration is not fixed, it is not constant, it is not uniform. So the acceleration changes, and it changes with respect to time. So as time changes, the acceleration changes. So first of all, velocity, we're going to look at these things. There's a relationship between velocity, acceleration, and also displacement. So if s is your displacement, and if your s, if you can imagine, is some function of time, then you can get your velocity. Velocity, remember, is a rate of change of displacement. So velocity is ds by dt. And we also can say that is s with a wee dot. So the wee dot means it's being differentiated with respect to time. So s with a dot above it means the s has been differentiated with respect to time. So your displacement has been differentiated with respect to time. Acceleration, then, we remember, acceleration is the rate of change of velocity. So it is then dv by dt, which is also then v dot. So you could also say then that your acceleration is equal to, I'll just jump to this bit, acceleration is d2s by dt squared, because to get to your acceleration, you've got to differentiate your s twice. Okay, this wee diagram is very, very good, and it's just really to show you how you get between the two things. So to get from displacement to velocity, you differentiate with respect to t, and also to get from your velocity to your acceleration, you again differentiate with respect to t. So if you differentiate to get from displacement to velocity to acceleration, then to do reverse this process, and what you must do is integrate with respect to t. So a integrated with respect to t gives you v, v integrated with respect to t gives you your displacement. And remember the last thing on that, which is very important, a constant of integration must be introduced at each integration. And you'll need to, there'll be enough information, hopefully, for you to be able to work that out, as we will see in these examples. Okay, so you can see a is equal to dv by dt. If it's a function of t, then to get your back to your v, you integrate that function of t with respect to t. Or I would have said, really, your v is just equal to the integral of a with respect to t. This example says, a body moves in a straight line such that a is equal to 6t, so your a is equal to 6t, and it says initially the velocity of the body is 2. We'll come back to that in a wee second. First of all, it says find a when t is equal to 5. So for part A, you're just going to sub t equals 5 into this equation. So your a is going to be 6 times 5, so your a is going to be 30, and the units are meters per second squared, so ms to the minus 2. Okay, part B, it needs us to find v. So remember, v is equal to the integral of a with respect to t. So if you integrate your a, it was 6t, so it's going to be 6t squared divided by 2. Remember, you raise your power and divide by your new power. And what we must remember is our constant of integration, c. So we'll tally it up, that's going to be 3t squared plus c. Now we're going to come back to this wee bit of information that says initially the velocity of the body is 2. So that tells you when t is equal to 0, initially your time is 0, v is equal to 2. So we're going to sub that into this equation here. So if we sub that in, you're going to get 2 is equal to 3 times 0 squared plus c. Anything times 0 is just 0, so that just gives you 2 is equal to c. And then you then can rewrite your equation. V is equal to 3t squared plus 2, and then we'll just say when t is equal to 3, that's what we had to find this question. Your v is equal to 3 times 3 squared plus 2. 3 squared is 9, times 3 is 27, plus another 2, your V is equal to 29 meters per second, ms to the minus 1. Okay, the next example says, a body moves in a straight line such that V is equal to, I'll write this down, V is equal to 2t squared minus 11t plus 14. Initially, the displacement of the body from some fixed point O on the line is 50 meters. Find the initial velocity of the body. So part 1, we'll just say put t equals 0, initial velocity, and your V is equal to 0 minus 0 plus 14. So your V is equal to 14 meters per second. Part 2, find the values of t when the body is at rest. So when you're at rest, that means your velocity is 0. So put 0 equal to 2t squared minus 11t plus 14. So we're going to use our sum and product to do this. So our sum is equal to minus 11. Our product is equal to 28. So two numbers that add to give minus 11 and multiply to give 28 are minus 4 and minus 7. So I'm going to rewrite my equation as 2t squared minus 4t minus 7t plus 14. And then we're going to factorize the first two terms completely, pulling out a 2t, leaving you t minus 2, and minus 7 times t minus 2, which means 0 is equal to t minus 2 upon 2t minus 7. So t is equal to 2 seconds, or t is equal to, and give the exact value, 7 over 2, and because that's a nice one, we can tidy it up as 3.5 seconds. So t is equal to 2 seconds, or t is equal to 3.5 seconds, are the times when your body is at rest. Okay, back to part 3 then. Part 3 we have got. Part 3 says, find the acceleration of the body when t is equal to 4. Now your acceleration, to get acceleration, you differentiate your velocity. So you differentiate your velocity, and you are going to get 4t minus 11. And then we'll just say when t is equal to 4, your a is equal to 4 times 4 minus 11. 4 times 4 is 16, minus 11 is going to be 5, and that is meters per second squared. Part 4, last part of this question, says the displacement of the body from O when t is equal to 6. So you've got to find your displacement. Displacement is your velocity integrated. So we're integrating, let's write down what we're integrating. We're integrating 2t squared minus 11t plus 14, integrating with respect to t. If you do that, you will get 2t cubed over 3 minus 11t squared over 2 plus 14t plus c. And then how on earth do we find our c? We look back at the question and it tells you, I will just highlight it here, it tells you initially the displacement of the body from some fixed point O on the line is 50 meters. So that tells you when t is equal to 0, s is equal to 50. So we're just going to put in t equals 0, s equals 50, which means 50 is equal to 0 minus 0 plus c. So your c is equal to 50. So that gives you s is equal to 2t cubed over 3 minus 11t squared over 2 plus 14t plus your 50. And let's go back and read the question, see what it said. It said find the displacement of the body from O when t is equal to 6. So I will squeeze this on here. Just say when t is equal to 6, s is equal to 2 times 6 cubed over 3 minus 11 times 6 squared over 2 plus 14 times 6 plus 50. File that into your calculator. I'm just copying down from my notes here. I'm hoping this is right. And I have got 80 meters. Okay, this next question is quite a tricky one, quite a long one. It says a particle moves in a straight line so that at time t seconds, its velocity v meters per second is given by v is equal to minus 10 plus 12t minus 2t squared. At time t equals 2, the particle is at point A on the line. Find the times when the particle is at rest. So similar to the previous example for the first one, we're going to put v equal to 0 to give you 0 is equal to minus 10 plus 12t minus 2t squared. Now you could factorize this in its current form, but I just like to bring it over to everything to the other side so that my quadratic term, the 2t squared, is now positive. So it's 2t squared minus 12t plus 10 is equal to 0. What we could do here is divide through by 2. Everything's divisible by 2. So t squared minus 6t plus 5 and 0 divided by 2 is 0. And then that would factorize nicely to give you t minus 1 and t minus 5 is equal to 0. So you've got t is equal to 1 or t is equal to 5. And I should have put a wee seconds in there. So 1 second and 5 seconds, this thing is at rest. Okay, part 2. Part 2 says find an expression for the displacement of the particle from A at time t. So your S, remember, is your velocity integrated. So S is equal to the integral, of minus 10 plus 12t minus 2t squared integrated with respect to t. So we'll just do that here and see what you get. You're going to get minus 10t plus 6t squared minus 2t cubed over 3 plus c. And there must be a wee bit more information in this question to allow us to find. Yep, there is. Okay. It says at time t is equal to 2, the particle is at point A on the line. And what we're doing is find an expression for the velocity from A. So we know basically when t is equal to 2, it's at A, so that means its distance from A is 0. So we're just going to put that in and see what we get. So 0 is equal to minus 10 times 2 plus 6 times 2 squared minus 2 times 2 cubed all over 3, and then plus your constant of integration. A wee bit of working out to do here. That's going to be 0 is equal to minus 4 over 3 plus your c, and then that means your c works out to be 4 over 3. So once you've found your constant, you rewrite your equation. Sn is equal to minus 10t plus 6t squared minus 2t cubed all over 3, and then plus 4 over 3. You could write that as 1 1/3. I think it's absolutely fine to write it as 4 over 3. Okay, the last bit of this question asks you to do. Sorry, get rid of these markings here so we can see the last part of the question. It says, find the distance traveled by the particle in the first 6 seconds of motion. Right. What a lot of people think you just do is you find t is equal to 0, you find your s, you find t is equal to 6, you find your s, and then that is your answer. That is unfortunately not how you have to do this. Now, they've been nice to us in this question, and they have talked us through this because the first part of the question, remember, was you find it in the times when this particle is at rest. So we know the times when the particle is at rest. Sorry, the times when this particle is at rest, we'd work them out to be t is equal to 1 and t is equal to 5. So we've a wee bit more working out to do. So we have got to find, the displacement when t is equal to 0, the initial displacement, the displacement when t is equal to 1, and we've got to find the displacement when t is equal to 5, and we've got to find the displacement when t is equal to 6. Because this particle has gone out, it's gone a certain distance, and then it's stopped at t is equal to 1, and more than likely it's gone back on itself, it's stopped again at t is equal to 5, and then more than likely it's gone on again to t is equal to 6. So we've got to find this distance, and this wee distance in here, and then this final distance. So basically we want to find the differences between here and here, difference between here and here, and the difference between here and here. That's what we want to do. So we're going to stop and we're going to go through and find all of our displacements, and then we can work out our total distance. So first of all, when t is equal to 0, just put 0 into your equation. I'm going to write my equation down and remember what was it? It was there. S was equal to minus 10t plus 6t squared minus 2t cubed over 3 plus 4 over 3. So when you put t equals 0 into that, you just get perfect answer of 4 over 3. We put t equals 1 into that, your s, what you're going to get. You show a little bit of working out and see what you get. And we'll just do that here very quickly. You're going to have minus 10 plus 6 minus 2/3, and then plus, let me get rid of those arrows, give myself a bit of room here, and that's going to be then plus 4/3. And if you work that out, what you're going to get is minus 10 over 3. Okay. The next one then, when t is equal to 5, you're going to have minus 10 times 5 plus 6 times 5 squared minus 2 times 5 cubed over 3 plus 4 over 3. And when you work that out, what will you get? I have got, hang on, 18. And then when s is equal to 6, I'm going to have minus 10 times 6 plus 6 times 6 squared minus 2 times 6 cubed over 3, and then plus your 4 over 3. And that for me worked out to be 40 over 3. So my distance, my total distance, is going to be the distance between here and here, so the difference between here and here, difference between these two numbers and the difference between these two numbers, and add them all up. So your total distance, I'm just going to write those all down again so we can set your t is equal to 0, your s was equal to 4 over 3, your t is equal to 1, your s was equal to minus 10 over 3, your t is equal to 5, your s was equal to 18, and your t is equal to 6, your s was equal to 40 over 3. Okay, now these distances, I'll do this in a different color just so we can see it. The distance between these two is going to be equal to 4 2/3 meters. The distance between these two is going to be 21 1/3 meters, and the distance between these two is going to be 4 2/3. So I've just done those on my calculator. So 4 1/3 and plus 10 1/3 gives me the 4 2/3. Then 18 plus 10 1/3 gives me 21 1/3, and then the 18 minus 40 over 3 gives me the 4 2/3. So my total distance then, total distance is 4 2/3 meters plus 21 1/3 meters plus 4 2/3 meters, and whatever that works out to be, and I'm just reading off my notes here, it was 30 2/3 meters. Okay, this example says a particle moves in a straight line so that at the time t seconds, and it also gives you a stipulation here that t is between 0 and 4, its velocity is given by this function. First part of the question says find the particle, the acceleration of the particle when t is equal to 2. So part 1, v is equal to 1.5 t squared plus 12, that was meters per second. So to get your acceleration is going to be equal to, acceleration is going to be equal to dv by dt. So differentiate that thing we've got above, you're going to get 3t, and that is it. Okay, and that's going to be meters per second squared. So find an expression for the displacement, find the acceleration of the particle when t is equal to 2. So just say when t is equal to 2, your acceleration then works out to be 3 times 2, which is just going to be 6 meters per second squared. Okay, part 2 says find an expression for the displacement. So displacement is going to be your velocity integrated. So that means we're going to be integrating 1.5 t squared plus 12 with respect to t, which is just going to give you 0.5 t cubed plus 12t plus your constant of integration. That's what your s is. And you also know it tells you in the lead up to the second question, at t equals 0, the particle's at a point A, whose displacement from the fixed point O on the line is 10. So basically it tells you at 1 second, your s is equal to 10. So when t is equal to 1, s is equal to 10 is the information you've got. So fire those in to your s. 10 then is equal to 0.5 times 1 cubed plus 12 times 1 plus c. So that's 10 is equal to 12.5 plus c, which means we better work out minus 2.5 is equal to c. So very importantly then, your s is equal to 0.5 t cubed plus 12t minus 2.5. Okay, we'll look at part 3. Part 3 says when t is greater than 4, the acceleration of the particle is minus 12. So that means it becomes a constant acceleration after t is equal to 4. It says show that the particle comes to rest when t is equal to 7. Now what I need to do first here is find the speed when t is equal to 4. I need to find the speed or the velocity. And then we can just use our constant acceleration formulas from there on. So we'll just say find. We'll use a proper word, the velocity, when t is equal to 4. So t is equal to 4, your velocity is going to be equal to 1.5 times 4 squared, and then plus 12. And then that becomes that your velocity is equal to, and that's just going to be 24 plus 12, that's going to be 36 meters per second. Okay, right, so this is the starting velocity. So this is the starting velocity for the next stage of motion. So we're going in the constant acceleration, your starting velocity then is 36. We want to find when something comes to rest. When something comes to rest, its velocity is 0. We know our acceleration is minus 12. And it says, show that the velocity comes to rest when t is equal to 7. We need to find your time then. So we're going to use our nicest constant acceleration formula, v equals u plus at. And fire in our numbers. 0 is equal to 36 minus 12t, which means 12t is equal to 36. 36 divided by 12 gives you 3. Okay, so time to come to rest then is equal to, remember we'd already gone 4 seconds, we've now gone an additional 3 seconds, which takes you to the required 7 seconds. Okay, and you need this bit here that I've just put in to explain, to show that you understand what's going on. So you couldn't just go from here, t is equal to 3, and then just jump, whatever comes to rest at 7 seconds. You need to say the 4 seconds plus the 3 seconds to understand what's going on. Okay, last part of the question, last part of this video, it says, find the total distance traveled by the particle between t is equal to 0 and t is equal to 7. Okay, for the first stage, it doesn't come to rest in the first stage. So if you look back at your formula for your velocity, it's not going to come to rest because it's all going to be positive. There's nothing to actually give this a negative velocity. If your t from 0 to 4, that's going to be 1.5 times anything between 0 and 4 is going to be positive, and then plus 12, it's all going to be positive. So it's definitely not coming to rest. We don't have to worry about that. So for this, all we need to do then for part 4. For part 4, what we need to do is find, on the first stage, we would need to find the distance traveled. So the first stage, remember, is t is equal to 0 to t is equal to 4. We will find the displacements of those. So when t is equal to 0, your s worked out to be minus 2.5. When t is equal to 4, your s is 0.5 times 4 squared plus 12 times 4 minus 2.5. So your S works out to be 77.5 meters. Okay, so we'll just work out our distance in the first stage then. Is the difference between those two things, so 77.5 minus 2.5, so 77.5 plus 2.5, which is just going to be, let's just write that in, sorry, 77.5 then minus 2.5, which works out to be a nice number of 80 meters. Our second stage, so for the second stage of motion, so this is from t is equal to 4 on to, I think it was t equals 7. Yep, t equals 7. We need to find the distance traveled. So this was constant acceleration. Remember, our initial velocity was 36. Final velocity was 0. Your time was equal to 3 because it moved 3 seconds. And we want to find the displacement. So I just write that whatever I'm trying to find, I just like put it equal to question mark. We're going to use the formula half u plus v times t. So S is equal to a half times 36 plus 0 times 3, and whatever that works out to be, half of 36 is 18 times 3 is going to be 54 meters. So then we're ready. We can say the total distance in the whole thing is going to be, we had 80 meters plus 54 meters that we've just worked out. And if you do that, you'll get 134 meters. And that is us done.